retired to go on to run her own business, Draco Productions, by the way, which for 30 years was a provider of telescopes and solar filters and stuff to the astronomical community. She became meteorites. In particular, she was fascinated by the things on the desk there. Indochinites, because they were cheap and plentiful. Meteorites are typically pretty darn expensive. Many of you have held her piece of the Arizona meteorite. It weighs 8 pounds. It is valued at over $10,000. That ain't cheap. Some of her meteorites include pieces of Mars and pieces of the Moon and pieces of the asteroid Vesta. And those, of course, were a pretty penny too. Her favorites were the beautiful green meteorites from Central Europe, the Moldavites. Some of them were made into jewelry. Beautiful Coke bottle green tektites. The most famous of the tektites is the one on the crown of the Pharaoh King Tut. That lemon yellow Libyan desert glass was more valuable to the Egyptians than gold or silver or rubies or diamonds. And it was their very particular sacred stone. But the Indochinites were discovered in the 1800s and 1900s by the French, of course, who named this area Indochina, which, of course, is not what anybody over there call themselves. But anyway, that's colonial history. But the French explorers did find these black stones all over the place. And many of them, of course, have been broken, and they're glass. Now, when we see this in a geology lab like this, it typically is obsidian, volcanic glass that's been blown up by a volcano. So, since it looks so much like obsidian, they supposed it must have been volcanic in origin. And they were partly right. Tektite, if you know your Greek, means twice melted. And it is now recognized to be impact debris that is blown up by a major asteroid or comet hitting a solid body. The easiest tektite field to see is at full moon. If you look to the south of the moon, at the crater Tycho, there are huge bright rays that go halfway across the moon. Those, of course, are tektites. They're glass. They're little tiny sequins, and they do what sequins do. There was a lady in the audience that had a beautiful sequin dress, and she didn't come, dag-nabbit, because I was going to point it to her sequins. But imagine me as Elvis with sequins, and there's a spotlight coming from the back of the room. If I'm over here, you don't notice it. But then I turn and face the audience, and the sequins sparkle right back at you. And then I keep turning here, and all of a sudden the sequins aren't so obvious anymore. So that's why the ray patterns on the moon are so obvious at what phase? When's the sunlight striking it head on? Full moon. Well, these glass beads are obviously, if they're shiny and glass enough, okay. Why are these so dark? Because the French scientists were partly right. They are partly basalt because of what they were made from. They had the misfortune of striking not Chicxulub, but the Belavan lava flows in central Laos. Those lava flows have been flowing for over 1 million years, and they didn't quit flowing until fairly recently. And during the time, 850,000 years ago, when a kilometer-wide asteroid struck southern Laos near the village of Mong Nong, that's where the crater gets its name, just like the Chicxulub crater is named for a small Mayan village in the Yucatan Peninsula. So it's just simply the location where the asteroid found ground zero. It's interesting to compare. As soon as you get to this, I'm going to turn it to Otto, and he's going to be talking about the record of cratering on the Earth. He is, of course, a scientist from the European Space Agency, and they did a lot of research on this, so this is going to be his forte. And but I will give you a little bit. Are you ready? Okay. Dr. Otto Richter is going to tell us about the big hits. And to be honest, this one isn't that big, but since it involves us and our ancestors, I'm still obsessed with it.
Mine is definitely giving me too much credit. Yes, I worked for 8 years for the European Space Agency, but that was as one of the token European scientists at the Space Telescope Science Institute in Baltimore. So I worked for the Hubble. I did go back for some period in 1993 back to Germany, where I'm originally from, and then came back to this country in 2012. Yes, I do know a couple of the people at the European Space Agency that work with various other satellites. The Giotto mission that flew to the Halley Comet, the Rosetta mission that was a pickup of material, but just like me, most everybody else is now retired. So, what was that? Oh, great, now it's restarting. Ain't that beautiful? So, Brian, you need to come back out again.
Yeah, our, what are we running, Windows 1?
You could come over to 14, I'll put you in a classroom better.
Oh, Mikey, yes. Gotcha. Oh, since you have the floor, you also have the mic. You'll leave it there. Okay.
Everybody in the last row should be capable of hearing me, right? Good. Yeah. Okay, so at the University of West Florida, I'm teaching 2 astronomy, well actually 3, but the third one is pretty rare. 3 astronomy classes. So one is the regular quote-unquote introductory class, which these days is called descriptive astronomy, so that you can do away with mathematics. Modern students don't like mathematics unless they study mathematics. So, and the other one is the Life in the Universe class that I teach, so basically astrobiology. And of course, for that, we are basically doing science based on a sample size of n equals 1. This place here, Earth, is the only place where we do know that life exists for sure. When it comes to the question of intelligent life, there are times when I have my doubt. But, okay. So, anyway, the Life of the Universe class.
There, you're back up.
Thank you very much.
Do it quickly.
In the Life of the Universe class, of course, what you do is you try to figure out how life on Earth, A, formed in the first place. How do you get from unorganic chemistry to organic chemistry? And as it turns out, extremely recent computer simulations of Turing machines have given an answer to that. It naturally arises if you experiment long enough. The universe has a knack somehow to create order out of chaos, even though that seems to fly in the face of the third law of thermodynamics, which says that the entropy can only increase. In other words, chaos only increases. Okay? But no, when it comes to this chemistry, that's actually not the case.
We're going to have to keep our finger on the screen, Brian?
What?
Please tell me it's not restarting.
It is. I have no idea why, but I have.
Is there another classroom we can use in this building?
No, everything else is locked up. This is the only one we have reserved.
I've got a key to building 1400.
Yeah. We've got a lot of small kids and stuff. We'll try to do the best we can. I'm so sorry. My apologies for feeding us these.
I could do shadow puppets. So sorry.
Well, anyway, obviously all the impacts, the large impacts that have happened on Earth, okay, have a bearing on the history of life on Earth. Life is actually pretty old. From some old fossils in Western Australia, we do know that life on Earth exists since at least 3.8 billion years. Now, the age of Earth by now is known far more accurately than it used to be known, like even 40 years ago, when people were just saying, 4.5 billion years. Now we know it's 4.557 billion years, and the error bar is 1 in that last digit. So the 7 could be a 6 or an 8. Okay. So.
Got you out though. I'm just
Yeah,
gonna
why
stay
don't
here.
you hold it there?
He's been entertained.
Yeah. And so, one of the things that in the final exam of the Life of the Universe class I'm asking my students is, how many sterilizing impacts have there been in Earth's history? So as you might imagine, sterilizing, of course, means all life dies, right? Well, I'd say we are here, right? So not all life died, okay? And so the answer has to be 0, and you'd be surprised about half the students answer 1 or more. So it's always amazing. I mean, you give an entire class, and then in the final exam, okay, one of the key questions. Anyway, okay. So you probably all know by now the famous story about the Chicxulub crater 66 million years ago, because it wiped out the last of the then living non-avian dinosaurs. Now the avian ones, okay, they live on in our birds today. The other ones, okay, are all buried below a little layer of ash. So obviously what happens is the energy of these bodies that are falling onto Earth, the entire kinetic energy, as the physicist says, during the impact, the thing is braked from 15 kilometers per second, about 10 miles per second. That's sort of the average impact velocities. Impact velocities, as you'll see in a moment, okay, actually it's already right here, it can go from 11 to 73.6, but this is in a head-on collision right into a meteor stream. So that only happens when Earth goes through the orbit of an old comet or asteroid that has been broken up into pieces and is now elongated along its entire orbit. We call those things today a meteor shower. There's quite a few of them out there. But anyway, let me go through it. I mean, craterization, okay, more than 300,000 impact craters are known on Mars that are larger than a kilometer. That's from high resolution orbital imaging, okay? Now, why are there so many and so few on Earth? You might ask. Well, on Earth, we do have a lot of wind and water erosion. That only partially exists on Mars. There's a little bit of wind erosion, but no water erosion anymore. There was a lot of water on Mars early on in its history, but Mars, being so much smaller than Earth, lost the ability to create a magnetic field, which is done via the liquid metallic core, the outer core in case of Earth, that is actually creating turbulence, and that generates a magnetic field. So Mars cooled off a lot faster than Earth ever will until the time that the sun dies. Okay? Even at that point in time, another 5 billion years into the future, there will still be heat coming from the inside of Earth. Okay? But Mars has already cooled down dramatically, and so the production of the magnetic field collapsed. That then meant that all the solar particles, cosmic rays, etc., could come freely down onto the atmosphere of Mars. There's no shielding through the magnetic field, and that ablated first just the atmosphere, and after the pressure in the atmosphere had gone down enough, then that meant that water just evaporated into the atmosphere and then was lost together with the atmosphere into space. The theoretical calculations about this have predicted that this event also happened at roughly 3.7 or 3.8 billion years ago, and those calculations can be pulled forward into the future to today to predict what a current evaporation rate should be for the atmosphere of Mars. And NASA had sent one of the probes with a satellite that was measuring the current evaporation rate of Mars, and it was absolutely spot on. We like that as scientists, when our predictions actually turn out to be true. Quite often they're not, but then we learn something. That is the process of science. That's the first thing I tell all my students in both classes. Science is not a body of facts. It's a process of learning. Okay? As Carl Sagan once famously said, it is the intelligent interrogation of the universe as to how it works. Okay? There's a lot of people that are not interested in how it works. That's fine. Okay? If they build houses or create furniture or whatever, everybody has their place. But some people, scientists, want to know more. Okay? So anyway, the moon, the highlands on the moon, are totally saturated with craters. Okay, you can't even count them all because the oldest ones have been basically destroyed, completely destroyed in most areas by newer ones. Now, on the near side of the moon, the younger side, where you have the mare, there it is possible to create a history. Based on the overlap of craters, you can always see which one is the older one. That's where a rim is broken by a newer impact. And the newest one is obviously the one where the rim of the impact crater is complete. Okay, that's the last one. Now, the dating of the material that the astronauts brought back from the moon has allowed us to do an age dating of all these craters on the moon. And so that brought on the idea that in our own solar system, there had been an early period where there was a lot of debris still flying around between all the planets that had the ability to rain down on the existing bodies, including, for instance, the sun, of course, okay, or our moon. Okay. The biggest impact in the solar system that we now know of happened on Ganymede, the largest moon in the solar system, the third of the Galilean moons of Jupiter. There was an impact by an asteroid that was about 300 kilometers in diameter. That would be today one of the large ones. Okay? And that actually tilted the axis of Ganymede. Okay? That's a very recent paper, about 8 weeks old. Okay? We don't have anything similarly large on Earth because Earth, being as large as it is, took a long time to solidify the surface. And in the very early history of Earth, there was a collision with a Mars-sized object, which is now called Theia, and that created our moon. The time scales on how quickly after the impact of this humongous object onto Earth, okay, how long it took to form the moon, those differ widely. There have been estimates that it might have taken up to 1 million years, and a very recent paper was saying it probably took 28 hours. That's quite the difference, 28 hours, 1 million years. Okay, but anyway, that's where the moon comes from. Okay, the simulations that have been done are now so accurate, you can exactly predict at what angle the thing came in, and that it would be breaking through the crust completely, so magma would be coming back to the surface, and so the surface of Earth was again a sea of magma all around. the impactor, okay, was of course the same thing. Its core, where all the heavy elements are, okay, would be sinking into Earth's core. And so some material from its core, very little of its core, a lot of its mantle, and part of Earth's mantle were thrown up into the air. And that's why we see the existing differences in abundances for the various materials between the moon and Earth. It's not identical. So the moon is roughly 80 million years younger compared to Earth. So it happened very early. Now, just very recently, yet again, there has come forth new studies that put doubt on this idea that there was this heavy bombardment period. In fact, it does appear that over the last few 100 million years in the history of Earth, the number of impacts has increased. You would not normally expect that because, after all, any body that falls on another planet, on a moon, into the sun, whatever, is no longer available out there to fall on something else. In other words, you slowly but surely deplete the space between the planets of material that can impact. So you would assume that the long-term trend definitely is one of fewer impacts. Okay. Well, when we look at when the heavy bombardment period was supposed to end, about 3.9, 3.8 billion years ago, okay, if that would have been true, okay, until then there wouldn't have been a way for a solid surface on Earth, and if the oldest life is already 3.8 billion years old, then you would have had to infer that life, it's just a given, okay? The moment there's a chance for it, it will happen, okay? Now we know that that's probably not quite true, okay? It wasn't the sudden burst, the so-called late heavy bombardment, about 3.8 to 3.9 billion years. But anyway, there's still a lot of stuff out there. It's being observed, and I will tell you a little bit about the spectrum in that. So we today still study impacts on the moon by just observing the flashes. Obviously, flashes don't happen when dust particles fall on the moon. It requires something a little larger than that so that you do actually see a flash. That means you must be having an impact velocity and a mass that is capable to, via its kinetic energy, to heat up the material so that you do see light. Okay. For Earth, okay, between 30 and 180 tons of extraterrestrial material, okay, fall onto Earth every day. Yeah.
Current events.
Yesterday.
Where did a SUV-sized asteroid fall yesterday?
No, Wednesday. Wednesday morning, 11:46.
Wednesday morning.
Yes.
The Philippines.
Yes.
Yeah, the Philippines had an SUV-sized asteroid, which we saw coming. The guys out at Mount Lemons.
Yeah. 28 hours before entrance into the Earth's atmosphere, which is extremely rare. Okay. Usually these small ones are hardly ever detected. I mean, it was not the first one that was known before, but that number right now stands at 4.
Did it hit anybody?
I haven't heard anything.
Completely burned up. No. No debris reached the Earth.
Yeah. Generally speaking, okay, if you have a metal asteroid or meteoroid that comes down, for that, even just something this big might leave something behind that falls to the ground. But for rocky ones, it must be the size of this room. Otherwise, it completely burns up in the atmosphere. Okay? So, anyway, all right. So, then the impacts on Earth, of course, are studied both visually. I mean, fireballs, right? That's best done at night. But these things don't wait for us, to have night and be able to observe. So obviously radar observations are good. The only problem, of course, is that both these cases here, okay, require that you have larger impactors, the real small stuff that is far more numerous and brings actually far more mass in, okay, is neither visible, okay, with light nor with radar. So upon entry, okay, obviously the friction with the atmosphere, okay, ablates material from the outer part of the asteroid, and it also excites the surrounding air, and that's why we see this as a fireball. This excitation of the air is what we actually see, okay. Brightness depends mainly on mass and velocity. Actually, it depends more on the velocity than on the mass. Now, this range here, okay, is observed, and it's kind of a theoretical calculation to do. Basically, what you look at the field of motion of all the bodies in the inner solar system. You calculate if they could impact, what velocity would they have, and of course then you have to take into account that the impact may not be vertical down, but in an angle, okay? And so you come up with this particular range, and that's actually observed. Now, there have been some impacts that had a slower velocity than 11 kilometers per second. That's only possible if man-made stuff falls back from orbit. Okay. One of the two of these cases has been identified with an existing but dead satellite. The other one is still under investigation. It happened a few years ago, and they still aren't quite sure what it was. But there is so many countries out there now that are capable to launch stuff into orbit, not necessarily always successfully, okay, that we don't really know everything, because some countries like to keep, especially their military launches, of course, a secret. Okay. Now, once we take all this into account, we only look for exposed impact structures on Earth, that is to say, the ones that are on land and currently can be easily seen on the surface. Then the prediction is that those larger than 84 kilometers, there should be 8 plus minus 3 of them. Well, there are 5 or 6, depending on how you count. Okay, so there is no significant deficiency. Yeah, maybe we do not know 2 or maybe even 5, okay, of them. But in all likelihood, those then happened so long ago that meanwhile tectonic plates, okay, moved and probably subducted some of these so that they're not on the surface anymore. Okay, all right, so anybody venture a guess where this is? This little picture here? Well, that is the famous Chicxulub impact 66 million years ago. This is the shoreline of northern Yucatan. Okay, Merida is about here, and Chicxulub is a little bit away from the coast, and it does have a marina directly on the coast, and the center of the impact was about a mile out into the sea.
I believe Cozumel is actually on the rim. Yeah, when you look at the Yucatan,
close enough.
We can go down and investigate it.
Cozumel Island is there.
Yeah. Okay, so this is the largest impact crater that people thought of until 4.5 years ago, when an even larger one was found. This is Freidefort. It's a little bit, it's relatively close to Johannesburg. Now you might be wondering, where is the damn crater? Well, it's in the lower left. Next one. Okay. So here's Freidefort. Okay. This is, and you can see in this particular case, there's several concentric rings. What happens is that the outermost ring, which is usually the one where, you know, it's highest, of course, erodes fastest. And with all sorts of other stuff that is going on, okay, the outer ones sometimes, okay, decay completely. So today's size of these craters is not necessarily the size with which they started out. I have a table later on to show that. So let's go to the next one. This one here is a geological map of one that's a little further away from us, right here in Pensacola. This is Sudbury in Ontario. Okay, another one of the really large ones. This was a cometary impact. Chicxulub and Freidefort were asteroidal impacts. Okay, the difference is Asteroids are purely rocky and metallic. Comets have volatiles on board. Ice, water ice, dry ice. That's why when they come into the inner solar system, they develop a tail, because when these ices begin to melt, then they're outgassed, okay, and that creates the cometary tails. If the tail is dense enough, then it will have two parts. One is going to be a so-called ion tail, which is directly pointing away from the sun, because the solar wind can actually impact the individual ions. And then the other one is the dust one that stays behind in the orbit of that comet. Okay, so there's sometimes a very small angle between those two. Okay, so this, but today, is a relatively elongated structure, and the reason for that is, again, surface motions. Next one. Okay, so I don't want to bore you too much with technical details. I probably even have long overrun my time anyway. But if you want to look at the velocity distribution, there's several networks out there in order of the 4, 1, 2, 3, 4, and then the models based on it. And as you can see, okay, this is reasonably agreeable. The difference between these is the mass ranges that are being observed. Okay. Let's go to the next one. Okay, so the size and mass distributions, okay, as you can see, this goes from 10 to the minus 16 to 10 to the minus 7, okay, and then from 10 to the minus 7 to 10 to the minus 2, and then 10 to the minus 3 to 10 to the 3. So it's different types of observations that we use. For the really big ones, we can use impact craters because they create them. That small stuff, okay, anybody want to venture a guess where we get these tiny particles measured?
Right ball.
So when the Hubble Space Telescope was launched, okay, one of the contributions of the European Space Agency was the solar panels. And the solar panels were created with the same technology that had been used by other satellites at the time. They were just larger because this satellite required a lot of power. And as time went on, the power level started to degrade, and ultimately it came to a point that they needed to be replaced. So they were brought back to Earth, the ones that were replaced and built by ESA. They were replaced by those built by NASA. And then all the micrometeorite impacts were studied on the solar panels from the Hubble Space Telescope. That's how we do know the tiny particle part. Okay? There's no other way to measure this. There was actually another satellite out there, the so-called Long Duration Exposure Facility, LDEF, that was meant to be out in space for a year, but because of the Challenger shuttle catastrophe, it ended up being 5 years up there. The data was still usable, okay, but these micrometeorites were almost all obliterated by larger ones when that was being brought back. So that small spectrum was lost, okay, because of repeated impacts. Okay, so the overall spectrum, okay, that's cumulative in mass here. I mean, 10 to the 15. Yeah, okay. Well, next one. Okay, so I don't want to go into details in this table. So the one in Western Australia, Yarra Barbara, okay, is originally was thought to be about 2 billion years, and it has been in the last year dated more accurately. So it's plus minus 5 million years there, but that's pretty old. And when you look, okay, Australia, Ontario, Quebec, Idaho, Montana, South Australia, Quebec, okay, South Africa, Queensland, okay. What does that tell you? The old continents have preserved impact structures for a long period of time. The newer ones, not so much. Okay, so Chicxulub actually, when it came down, that part was a shallow sea. Okay, so today half of the crater is on land, but subducted. Okay, and it was fully underwater when it happened 65 million years ago. Now, how deep the water was, I don't really know. Anyway, when you look at this, okay, the large ones, larger than 85, okay, and then you see if they are exposed. Depending if you count Chicxulub into it or not, it's 5 or 6, okay. So that's really not far away from the theoretical prediction. So we think, we might perhaps find another one if we really look carefully. But even these large ones are not easy to find. Okay, imagine the difficulty for even smaller ones. So, well, that's basically all I have to say here. Yes.
Would Chesapeake Bay just fit into that chart? I've been reading some stuff on the Chesapeake impact there, and
there are some
Marma.
It is here.
Yeah, there it is. Okay.
So.
Didn't read down far enough. Yeah, there it is. The tech types in Georgia come from the Chesapeake Bay.
Yeah.
By the way, a reminder, why did it take so damn long to find
What is on? Don't do it.
the Mong Nong crater? It's like 10 miles long. Why wasn't it easily discovered?
Because it looked like natural surroundings.
No, worse than that. Why don't we see the old craters on the moon? What happened to them? Come on, you know. Filled up by what? No, the Balaban lava flows. Remember the Chicxulub, the Mong Nong impactor had the very bad luck of hitting one of the most volcanically active places on the earth. It was already sloppy. It slopped out a lot more stuff, which is what you have in your hands now. And then it got filled in very quickly. And so we had to use, again, as you were just saying, LiDAR to get through the layers of lava and find out, by golly, there's a crater sitting down there. Now, realize, oh, by the way, I did some quick calculations in terms of Otto's presentation of the energy involved. Okay, we believe the Mong Nong impactor was, I think you were thinking on the order of 10 kilometers for Chicxulub. I'm thinking maybe 1 kilometer. So we're talking about something 10th the size, 1,000th the mass, 1,000th the kinetic energy, because you're going with the volume being 4/3 pi r. Come on, geometry fans. Volume of a sphere is 4/3 pi r cubed. Yeah, cubed. So what I get for the volume of the impactor was about 4 times 10 to the 9th cubic centimeters. The mass, cubic meters, cubic meters. Therefore, the mass, we're going to go with Otto's projection that it's probably asteroidal, probably stony, and that's going to be about 3 grams per cc. The average density of the Earth's crust is about 3 times that of water. So it's going to weigh in at about 1.3 times 10 to the 10th kilograms. I'm going to go with a very low velocity because it was easier to deal with. I'm going to say that the impact velocity would be about 3,000 meters per second. I think some of those you were saying were, but this would be at the low end. So when we go out, the energy is 1/2 the mass times the velocity, kinetic energy, mass times velocity. So this comes up with joules. 6 times 10 to the 16th joules. For comparison, Hiroshima, 5 times 10 to the minus 10 to the 14th joules. So this means we're talking about something on the order of 10,000 Hiroshima explosions that hit Laos. Now again, this didn't even fit on the chart that Otto was just showing you. But that means that Chicxulub would be about 1 million times more powerful than Hiroshima. If you do want to make a comparison with the current political state and the scientist countdown, the, minutes till midnight, if you took all of the Russian, Chinese, American, French, British, yes, the Israelis, and put all of those nuclear weapons in the middle of Laos and were to ignite them simultaneously, they would have approximately the same explosive energy of the impact that hit Laos 850,000 years ago. So while it might not have been an event that was going to wipe out all of the extremely successful dinosaurs, for the very primitive Homo erectus, especially if you live anywhere here, it was going to be hell to pay. We find, and by the way, if you want the actual reference list, I ran some copies of it, and all of this is available online at the link that's on the bottom of your sheet. So if you go to that link there, you will find this third page. I didn't run it off because I figure most of you are not going to look at it. But if you want the actual reference, yes, Brian, you need one too. And I'll say one for you. Okay, the reference list is natural history. This is why I have had so much trouble. Are you picking me up okay, Ed? Yeah, okay. This is why I'm having so much trouble getting anywhere with this. Because I propose it to Astronomy Magazine. This is paleontology. This is archaeology. We're not interested. I propose it to Scientific American. This is true to versus subject, you know. We don't have enough data yet. We are at the same place right now that the Alvarez father and son were in 1973 when they found this layer of iridium. Something interesting must have happened to wipe out the dinosaurs, and here seems to be the event beyond which we don't find the non-avian dinosaurs, and below it we find them in abundance. The dinosaurs were not dying out. They were taking over the earth. Us mammals. Hey, who came first? The ruling mammals or the ruling dinosaurs? The ruling mammals. Yeah. Dimetrodon was not a dinosaur. He was one of us. He had the canine dentation. He had the 3 different types of teeth. He had a mammalian, not a reptilian skull. He might have laid eggs, but he probably was warm-blooded, which may be why he needed to sail. But our ancestors ruled the Triassic. And then we got whooped. The dinosaurs came along, they were erect, they were fast, they were smart, they were hungry, and we either went up in the trees, our ancestors, or we went down underground, the gophers. And for the next 150 million years, T-Rex and buddies won the game. And then finally, through the grace of not an asteroid, by the way, as of a few weeks ago, we now have enough debris from the impactor to say pretty sure just how extremely unlucky T-Rex was. It wasn't an asteroid. It was a comet. It was a KBO. It was more like Pluto than Mars. It came from way out yonder. So the dinosaurs were just incredibly unlucky. And I say, well, hell, if you've been around 150 million years, you've got to figure that sometime or other, something bad's going to happen. I mean, the law of averages will catch up with you. And in the case of T-Rex, it surely did. But anyway, so what did it do to us? Well, it wiped us out to the point that there were a few surviving remnants of humanity. 2 of them were isolated at the far eastern edge of the impact zone. On Luzon in the Philippines and on the island of Flores. Have you ever heard of the Hobbit people? I know that the estate will sue the dickens out of me for saying that, but this is what they've been known as. Homo florensis was discovered about, what, 20 years ago now, Brian? Yeah. We've known about them for about 20 years. They were, Leo, stand up. He would have been a giant amongst Homo florensis. Orion, stand up. That is your average Homo florensis female. They had a brain size a third that of Homo sapiens. So they were very tough. They made tools, they buried their dead, they used fire. We think you gotta have a big brain to be smart. Ask the octopuses. You've all seen my octopus teacher. Yeah, he's a lot smarter than a human, no doubt about it. She is. She's smarter than a human. Anyway, so they probably underwent dwarfism on islands that are separated for a long time. If it's a fairly small area, the species, whether they're hippopotamuses or rhinoceroses or elephants, tend to shrink. And that probably went for Homo florensis and probably Homo luzonus as well. But they made it. They survived, and for 800,000 years, these people thought God was really good to just them. Because all those big, mean Homo erectus that were chasing them from their homelands got fried alive. There were no human beings anymore over this whole area of Earth. The people at the outer edge, right here, Luzon, Flores, they were still alive. There were humans there. Java man, Peking man. He's older than this impact. But we don't find any more of them for many hundreds of thousands of years. There must have been this huge area of India and Indochina and most of Indonesia that was wiped clean, and it would take mankind and other biota a long time to re-inhabit this dead man's area. And there probably were all kind of mores, taboos. This is where Granddaddy went and he got burned up, that kind of thing. So we were down to about, as far as us Homo sapiens that are still around, we think now from the DNA code there were 1,000 breeding Adam and Eve pairs left. This is all we find in our DNA. We were down to about 1,000 mothers and fathers. And some of them probably were Luzonus and Florensis. Because I have a feeling when the Australian Aborigines got to Flores about 50,000 years ago, these Flores people had been so used to thinking that they were the apple of God's eye. God, you're big. And the Australian Aborigines said, you're small, but you're cute. In the Philippines, I was accused of being racist for using this term, but it is the only term I have been able to find. There are in the southern Philippines, near Luzon, the Negritos, dark, short Filipinos. The Spanish, of course, call them that, and I can't do anything about it. But the complexion and the stature maybe be some Homo luzonus DNA. In Caledonia, in New Guinea, there are dark-skinned people, darker than anybody in Africa today, that may be carrying some of the genes of Homo florensis to this very day. By the way, what percent Neanderthal are you? I'm 2. Anybody beat that? Nobody here is more than 2% Neanderthal.
You got them zip.
Mary was 3, and she was 10 IQ points higher than I am. So I don't think Neanderthal genes are anything to be worried about. She was 3% Neanderthal, I'm 2. But everybody here is at least 1%. I know from the complexion of your skin. The only people who are not Neanderthal, and there are very, very few of them left after all of the years of slavery and colonization, are pure African. And all the Afro-Americans, yeah, they got some Neanderthal by this point, you can bet. So, there's this great mixing going on. So I think that this was a very critical juncture in human civilization and almost wiped out all of our ancestors. The survivors were probably mainly in Africa, and they did, of course, repopulate the planet, but it would take them hundreds of thousands of years to make up for this huge hole in human evolution that this big impact wiped out practically every one of us, but for about 1,000 Adams and Eves. In conclusion, evolutionary, I give the floor to perhaps our successor, ChatGPT. If you will do your best Alexa impression, while Neil deGrasse Tyson would not agree with me, AI did. Here's what AI said.
You really want me to do the Alexa voice or my...
If you can, please. You had drama. I know you did.
The Mount Nang meteor impact would have had a profound influence on human diversity around 800,000 years ago. The immediate environmental destruction and subsequent climatic changes would create significant selective pressures, leading to population bottlenecks, forced migrations, and increased genetic mixing. These factors combined would shape the evolutionary trajectory of early human populations, driving technological, cultural, and genetic adaptations that contributed to the diversity observed in later hominin species.
Thank you. You have heard it from Alexa. Do you have any questions? Keep up with it. You have heard the first public presentation, but maybe not the last. I don't think so. I think that Mary and I are on to something. This started with her and her collection of Indochinites, but it's led us to the point that we may be looking at how the science have all mixed and merged to come to a very interesting juxtaposition. Stay tuned. Good evening. Oh, Otto, please.
Yeah, I have another remark about that. The geneticists, when they study these bottlenecks, I'm personally aware of 3 of them. The one that is best studied because it's most recent is about 7,000 years ago, when there's a bottleneck in the male population only. There was a time when there was only 1 male for 17 females on Earth. That coincides with the time of transition from hunter-gatherer to settling down agriculture. And it is assumed that it's largely because of the males fighting for territory. What's different today? Most don't have the ability to do that. Okay, the next one back is 74,000 years back, and that one was an actual bottleneck. It is estimated that somewhere between 3,000 and about 6,000 humans survived. And that was the Toba supervolcano explosion. The timing of both these events, one from genetics, the other one from volcanology, coincide perfectly. Okay, so there is a causal connection. Now the other causal connection we have is for Chicxulub, because not a single dinosaur skeleton has been found above the so-called KT layer, which is enriched in the in iridium especially, but also the other noble elements. And so it's clear, okay, even though the biologists initially were trying to fight the Alvarez father-son duo, saying that the dinosaurs had started 110 million years ago to go extinct, it was the ones that were still left that suddenly were gone all at once. Okay? If you don't have any light from the sun for anywhere between 4 and 6 months, which is estimated to have happened at that time, then if you're cold-blooded, you don't wake up. If you don't wake up, you don't eat. If you don't eat, you whittle away, and you don't procreate. Very simple. Okay? And so that's why they're all below the ash. Okay? Now with this particular one, you need to look at the time scale there in detail, Wayne, because the previous bottleneck, the genetic bottleneck, is dated to somewhere between 920 and 813,000 years ago. The impact in Laos is dated to 790,000 years ago, after the bottleneck, which left about 1280 Homo erectus. Homo sapiens was not around at that time. At least not in sufficient numbers, not in that area. So it's like the Toba supervolcano has sometimes been said, that it basically caused the Ice Age. Well, it came exactly at the tail end of the Ice Age. It might have prolonged it a little bit, okay, but it's not the cause. But it was the cause, okay, for that particular genetic bottleneck. There are statistical calculations on how many individuals you need to preserve a population worldwide, and the number is roughly 4,159 plus minus about 300. These are things that take into account the frequency of women that never give birth, early child death, males fighting back then with each other and all that kind of stuff, accidents, what have you. It tried to model everything, puts a spectrum on top of it, and then they ran a complete simulation through. The error bar is for the mean. Then there is the other thing. These 1,280 people that were left at the time, of course, would not have lived in one place. And that's the reason on why it took enormous amount of time, several 100,000 years, to repopulate the planet so that we are now 8 billion. Okay, because groups that are less than 30 people will die away. You need at least 30, better 40 people in a tribe, in a group, okay, and that you have enough, breeding going on. Okay.
You have to have grandparents for babysitters.
Yeah, well, but anyway, so when you see where you find, skeletons of Homo erectus and early Homo sapiens, okay, they're widely distributed. So these were probably just all small troops. And after such a catastrophic event, which anything that is about 1 kilometer in diameter can cause, okay, depends on the specifics of the impact. Now, in this particular case, the magma that overflowed the actual impact crater was much, much later, okay? Had nothing to do with the impact itself. That came hundreds of thousands of years later.
Made it very hard to find.
And that's why it was hard to find. It was just like Chicxulub. That was the geological survey where they actually found it first through geomagnetic measurements. And then they did the microgravity measurements, and then these circular structures, came about, and then they looked at it, and then the ring of cenotes there, these sinkholes in Yucatan. There are cenotes outside the outer rim of the Chicxulub crater. Okay, that's because all of Yucatan is a lot of limestone, and rain, no matter how clear the atmosphere is, unpolluted by modern technology, it always is a tiny bit acidic, which is terrible for limestone. And so there are these sinkholes. There's usually salt water at the bottom, and then and the fresh water on the top in these things. Makes for interesting life in there.
By the way, if you are as much into natural history as Mary and I were, we have over 100 pounds of fossils, and Mandy and her kids are coming over Sunday afternoon to help me finish up the fossil display for Pensacola Beach Elementary School. But if any of you have kids, or you are a great fossil hunter right here, Brian, you got to get over there and take a look at all the junk that Mary and I accumulated. We went to Ardmore, Oklahoma, Lake Texoma, Arkansas, Tennessee, Kentucky, Birmingham, Montgomery area, and of course we did work with the Florida State Museum at Camp Creek in Walden County. So we have stuff that goes back from the Ordovician all the way up to the ground sloths and stuff. So if you want to get with me, contact me through Facebook, Escambia Amateur Astronomers, Ed McGowan. He is our presidente, and he and I are co-moderators. And we have a site there. You do not mention either presidential candidate or we kick you off immediately. It is strictly science, and we keep it nice and clean. And so join us. It has 4,300 members all over the world, and some of the most outstanding astrophotography you will ever see is published there daily. So please join us. We will be at Pensacola Beach next Friday, if it's clear, and Saturday. So by all means come out. By the way, she was boasting about Saturn, but all of you will have a big disappointment when you look at Saturn next Friday night. What will be almost missing?